Problem 28. Find the index of the first occurrence in a string. So basically, here we have a haystack. Yeah. Two strings are given. One is haystack, the other one is needle. And within this haystack, if you can spot any occurrences of the string, like you can here, then you should return the index, the starting position of the first occurrence. Okay, that's what we have to do. Now, most of you are probably now wondering that, we could just simply do, there is an index of function. So we can just use haystack index of needle, right? And that's it. That would be it. But you can probably guess that that's not the intended solution. The authors of the problem just want us to practice doing whatever index of is doing. But actually, we're not going to do exactly what index of is doing because it's optimized and it's very efficient. It's so it's using various approaches, I'm sure, which is order of n plus m operations, where n and m are length of a haystack and needle, respectively, right? But that's not what we're going to do. We're going to do a very simple solution, which will be roughly O n times m. Yeah, so significantly worse time complexity here. But I'm sure this will be enough for our little situation. Okay, so what should we do? You know what? Let's try to examine every starting position within the haystack, okay? And see whether this starting position is a starting position of the needle, yeah? Now, to do that, let's have a variable called start, okay? Logical name. And it should go from 0, from here, to, well, almost to the end, right? Somewhere, there is no point of looking whether B can start at the very last position here, because it depends how long your needle is, right? So if you think about it, the very last position we need to examine is the length of haystack minus the length of needle. And that would be inclusive. And to kind of quickly verify this, I'm not going to prove this. Just think about if needle and haystack were exactly the same, then this would be 0. And that's clear that the 0th position, the index 0, is the last position where you want to try to match these two strings of exactly the same length, right? So we're going to do start from 0 to this. Let's do that, actually. Let's quickly write this loop. So for let start equals 0, start is less than or equal to haystack length minus needle length, right? And then plus plus start. Okay, now back to our drawing. Let's say start is pointing somewhere here. Now, let's now count how many elements, how many characters are equal, starting from this position, how many characters are exactly the same as, the respective character from the needle, okay? So that will mean we need an inner loop, a second loop inside. So the counter of that loop, let's call it I, okay? Again, maybe not a great name. It is a counter of the prefix that matches. So maybe you can come up with a better name for this. So let I equal 0. So I'm going to define I outside of the inner loop because I'm going to need, so if I have the loop here, I'm going to need I after that inner loop. And what I'm going to do outside of the loop is I'm going to say if I equals to needle length, and I should return start, correct? And just to not forget, here I will return -1, which means, so basically this return -1 means from every starting position, right? So I went inside this outer loop, I went through every starting position. I tried to match and count inside I how many letters match with needle, and not even single time the number was the entire needle's length, right? Because otherwise then I would have returned prematurely, but I didn't. So I ended up on this line 8, which means no occurrence of needle was found. So return -1, right? So the only thing that remains then is to write this inner loop here, which will basically promote this I and make it equal to the precise number of elements that are matching. So for example, if we are starting here, right, then I would start from 0, but once we come out of the loop, it should be equal to 2, because we have 2 elements, 2 characters that match, right? So in order to do that in this loop, what happened to my, sorry, I have to, my pen was rolling around. So now the loop. Should I do a while loop or for loop? Let's do a while loop. So while something plus I. And that something would be while I is less than needle length and, but before I write and, just think about this, I is less than needle's length. Yeah. If I is less than needle's length, then not only am I pointing with this I, I'm pointing somewhere inside of the needle, but also if I do start plus I will be pointing somewhere in the haystack. I'm not going to fall off outside of the haystack. So there is no need for me to, in addition, check whether start plus I is still less than haystack's length, right? And the reason for this is, you may have guessed, because outside, I know that start is maximum could be haystack length minus needle's length. So I'm taking haystack's length and I'm subtracting needle's length, and then I'm adding something which is I, which is strictly less than needle's length. So I'm subtracting the full needle's length and then adding back not the entire needle's length, but something slightly less. So I'm not going to go back. This is not going to take me back all the way to haystack length. It will be at least somewhat smaller, which means maximum this would be haystack length -1. So, which means I could easily say haystack start plus I, and I can be confident that this does not go outside of the haystack string. So, but this should be the same as needle I, right? So I need to, just to go through this once again, I needs to be less than needle's length, and then I can check this. This must be true, and if true, then I will increment I. That's our entire inner loop. Okay, let's try this on the pretests. Okay, pretest passed. Now the actual tests. And here we beat 100% of solutions in terms of speed, but in terms of memory, we beat about less than 10% basically, which isn't great. So what the heck? I would expect the very opposite here. How did I abuse memory? while I have a variable start and I have I and nothing else. Okay, that means probably just the inefficiency of the language itself, right?